Hello, this is Chemistry Central Science 11th edition. We are in Chapter 4 on aqueous reactions and solutions in stoichiometry. And this is the end of the chapter, questions 47 and 49. Which circled region of the periodic table shown here contains the most readily oxidized elements? Okay. If there's two words that are opposites of each other, you have oxidized and reduced. Okay. Oxidized and reduced. So reduced is easier because you're thinking of charge. If your charge is reduced, you become more negative. Okay, so this becomes more negative. If you're oxidized, that's the opposite. So it's harder for me to memorize oxidized. I just think of it as the opposite of reduced. If reduced is taking a more negative on you, then oxidized means getting negative taken from you, because the only thing that can be stolen is the electron. The proton stays in the nucleus, so it stays with you, but the electron can be transferred back and forth. So if you get your electron stolen, you become oxidized. If you steal an electron, you become reduced. Okay, you stole it, so you become reduced because you're stealing an electron. So an oxidized would be a positive, becoming more positive, and reduced becomes more negative. So I look here at A, B, C, and D, and I ask myself, which one of these would become more negative? Okay, so which one is more likely to steal an electron? The ones on the right, becoming like group 8, or the ones on the left? Does group 1, for instance, become negative 1? What is its charge? What would group 1 become? Well, it becomes positive 1 because it gets its last electron on the outer shell gets stolen, and now it becomes a positive 1. Well, what about group 7? Group 7 wants to become like group 8, and it steals an electron to become like group 8 and becomes negative. All right, so these guys, the ones on the right, become the ones that become more reduced because they are the ones more likely to steal. The ones on the left become more oxidized because they're the ones more likely to get stolen from. All right, so your answer then is A. A is more likely to be oxidized. And then what is your second answer? What is the least likely? It would be D. The most likely would be A. The least likely would be D. Right? All right, 49. Determine the oxidation number for the indicated element in each of the following substances. Well, there's only 3 that we know. Okay? I know that fluorine is negative 1. I know that oxygen almost always is negative 2. And I know that hydrogen is positive 1. And that's all I know. I also know where they live. Okay? Group 7 tends to become negative 1. Group 6, negative 2. Group 5, negative 3. Okay, that usually tends. Group 1 becomes positive 1. Group 2, positive 2. Group 3A becomes positive 3. Okay, so I can make those guesses. The rest of it I get from the idea that all of this is always going to be 0. Whenever you have a compound, all the charges cancel each other out, except in the case where you have a charge. If you have a charge, all of these add together to make a negative 1. If there's no charge, all of these add together to make 0, 0, 0. Okay, so if I know 1 and I know that they add up to make a 0, or they add up in this case to make a negative 1, I can figure out the other ones too. All right, so that's what they're asking us to do. So let's do SO2. Well, I know that oxygen is negative 2. So if I have SO2 and oxygen's negative 2, and I've got 2 oxygens, what's my charge? Negative 4. So what if SO2 is 0, what does my S have to be? Well, it has to be positive 4. I hope that made sense. Do you see? I can figure it out from the molecule. What about Mn and MnO4? All right, so I have Mn CO4, and it's a -1. Well, oxygen is -2. How many -2's do I have? 4. 4 times -2 is -8. So I have something plus -8 equals -1. Do you see the charge there? It's negative. So what plus -8 equals -1? Okay, well, it's 7. 7 minus 8 is -1. All right, so the Mn, oh, I missed one, didn't I? The Mn is +7. Let's go back and do B. I've got COCl2. I know that oxygen is -2. I know chlorine is in group 7. So what do you think it is? It normally would only need to steal 1. It becomes -1. So this becomes, there's 2 -1s. This is also -2 because there's 2 -1s. And -2 and another -2 plus the carbon equals 0. Do you see? So I've got -4 and I need a +4. So this is going to be +4. Okay, last one. Br in HBrO. Well, this is -2. This is +1. Okay, so that becomes -2 plus 1 is -1. Br has to balance with -1. So Br becomes +1. Okay, these are called oxidation numbers. And you figure them out, and as the oxidation number goes up, then you have an oxidized, it's a oxidation reaction. If for instance, bromine goes from normal bromine as 0 to a +1, then it means that has been oxidized. That's what's happened in that reaction. And that's where we're going with this for the rest of this chapter. Okay, great.